Hi everyone, welcome to the channel. In this video, we're going to be solving a question from unit conversion and statics. So we have this question that we know a man weighed 155 pounds on Earth. We need to find his mass in a slug for the A part. B part, we need to find his mass in kilogram. In C, we need to find his weight in Newton. And there's a scenario that if the man was on the moon, where we know the acceleration of gravity is 5.3, we have to find his weight in pound and his mass in kilogram. So there's a big message in this question, and that would be that regardless of the acceleration of gravity, the mass would be the same, and that will come from the second law of the Newton, which F is equal to mass times A. And if we want to change the F to weight, we'll have M times G, which is the acceleration of gravity. So if we are talking, or if we are in the scenario that we are on Earth, the weight on Earth, it would be depend on the acceleration of gravity. And in moon, same scenario, we'll just have the acceleration of gravity on moon. So regardless of the acceleration of gravity, we have the same mass, but the weight can be different due to the difference in acceleration of gravity. So let's go over the units for these. So for the SI units, we have Newton for force as the unit. We'll have kilogram for mass, and we'll have meter per square second. For the acceleration, there is another units for each of these. We'll have also pound for force. We'll have slug for the mass, and if you report these, the acceleration of the formula would be based on foot per square second. So this question is mostly about unit conversion between these different units. So let's start with the A part, where we have the weight of the man 155 pound, which is equal to mass times G. Since we are on Earth from the question, this will be the acceleration of gravity on Earth. And if we want to find the mass in a slug, we'll have 155 over the acceleration of gravity on Earth based on the foot per square second will be 32.2 foot per square second. So we'll just simply have 32.2 in here, and that would give us 481 point, would be 4.81 slugs. So for the B part, we just need to find his mass in kilogram. We know the mass is 4.81 slugs, and we simply need a unit conversion for kilogram to a slug. And we know one slug equals to 14.59 kilogram. That way we can cancel out the slugs, and we'll end up with kilogram as the unit, which is 17.2 kilogram. And in the C part, we need to find the weight based on Newton. So we know the weight is 155 pound, and all we need is to find what is 1 pound to Newton, and that would be 4.4482. So we can cancel out the pounds, and this would give us 689 Newton, and that would give us the C part of the question. So the last two parts are in a condition that we are on the moon. So that was, as I was saying at the beginning, regardless of the acceleration of gravity, mass would be the same. What would change is just the weight. So in the D part, we need to find the weight in pounds. So we need to find the weight of the man on pound on Earth. So we simply need to do mass times acceleration of gravity. This time is moon, which we know from the question is 5.3. So as long as we have the weight based on slug, that should be easy to find. We know the mass is 4.81. And we have 5.3 for the acceleration of gravity, and that would give us 25.5 pounds. So we just need to be mindful of the units that we are using. So since we have the acceleration of the gravity on moon based on foot per square second, that means we need the mass in a slug, so which we found in the A part 4.81. So simply that mass times the acceleration would give us the weight in pound. And the last part of the question in E, we need to find his mass in kilogram. We already know the answer to these questions. I was explaining at the beginning. Regardless of the acceleration of gravity, the mass would be the same. So we'll get the same answer for the mass. And from this part, we still have 17.2 kilogram for the mass. And that would be the final answer for this question. See you guys next time.